Hello, guys.
Good morning.
So, good morning.
Hi, good morning.
Hi, Michael Ajay. Good morning. Hinsapu. Good morning. Ramesh. Patrice. Everyone, good morning, guys. So, guys, today in this class, we are just going to start with the statistics, guys. Guys, I've shared a Colab link file to you. Okay. So before we just begin with the statistics, okay, I just wanted to give you some information regarding the quality of the data. So as you know already, in data science, we are actually working with the raw data. So you are all aware of this one, guys. I hope you can able to hear my voice. Can you please confirm me, guys? Am I audible to you?
Yes, you are.
Yes.
Yes, everyone. Okay, fine. So because today I've just connected with the two different systems to make sure that I'm actually reaching you. Okay. So you all aware of this data science? It's going to be the we are just going to get the data from the raw source, and it's never going to be like straightforward, right? We always used to get data from the multiple real-time sources in the different formats, and all these requires a cleaning, conversion, okay, transformation before it can be used. We all aware of it. Still, we get the data which has been prepared by the data engineers also. Still, the noise, error, missing values are going to consist in it. So these are all going to be like the factors actually. So factors what are the factors that is actually impacting these noise in your data? You need to understand about the factors. So factors that affects the data quality. Affects the data quality. In general, we have been discussed about the factors like noise, right? Generally, we have discussed the factors are going to be like noise. So you do have like several factors, okay, like randomness. Randomness is one factor. Error, noise is also another factor, which is a in turn type of the randomness. Error, missing data, inconsistent data, and imbalanced data, because your data is going to consist of all these type of incorrectness, outliers, redundancy, right? So granularity, etc. Okay, guys. So we are just going to explore the few aspects of the factors that affects the data quality, quality. So in the EDA, the first step of the data science is actually the EDA, like exploratory data analysis. In this EDA, we will be exploring all these type of the factors that is actually originally present in our data, and we are supposed to handle it mandatorily. Okay, we are supposed to handle all these type of in general term, we would be referring it as a noise, guys. Okay, the first one is randomness. So what is a different thing? What is a different unique thing? We will be exploring it, guys. I hope, are you getting, guys? Do you understand? So what is a randomness? Randomness, it's going to be like natural variability. Natural variability, guys. It is actually the natural variation that actually occurs in the data. It is going to be like unpredicted variation. If randomness are going to be in the data, these randomness in the data, it is going to give you some unpredicted variation. You cannot able to predict this variation because this occurs naturally. Unpredictable variation. Even under controlled conditions, even the data has been recorded, okay, under controlled conditions, or even when the system is working properly, okay, controlled conditions, even when the system is working properly, or even when you try to control or measure something consistently, even when you try to measure or observe consistently, this natural variation or unpredictable variation is going to occur in this data consistently. All right. So what is this actually? So what is a natural variation? It is actually not a noise, guys. It is not a noise. It is an unexpected wiggle, actually. It is not a, which means it is not a mistake. It is not a mistake, or it is not a error. It is also not considered as a not a error. But it is going to be like unexpected wiggle, which means it is an inherent uncertainty or the process of the environment or the process of environment. So let us discuss with an example, only then you will understand. So I hope you guys can able to understand. Do you understand my handwriting, guys? Can you able to follow up my handwriting? Should I write still a little bit slow? Is it okay for you? Everyone?
All right, can you take this again? Like, can you take this randomness again?
Okay. So randomness, let me tell you. So randomness, it's going to be like natural variability in this data, guys, which means that variation is going to be like unpredictable variation. How the data is going to get varied, you cannot able to predict it. It is not a mistake, not an error. Okay. You cannot able to avoid such a variation because even these observations of the data have been recorded even under the control condition, even if the system is working properly, okay, properly, or even if it is going to be like a consistent environment, okay, these natural variation are going to be occur in this data. So what do we want to do? We should not neglect this randomness. Though randomness gives you large any variation in the data, you should not neglect it. Instead, you wanted to handle it. Okay, let us see what is the type of example. See, for example, if a medical test, if a drug is going to be tested, right? If a drug is going to be tested, so consider about the medical testing. You do have a patient's data, like no patient A or B, okay, both the patients. These patients are all having the similar type of a age group. Their age group is going to be like similar, okay, like similar type of a age group, right? So their blood pressure is actually quite normal, I mean quite the same, okay, they both the patients blood pressure is quite similar before applying this medical test, right? After the medical test, if the BP has been observed, okay, after the test, if the BP has been observed for both patient A or patient B, the patient A might be fall by 10 points or 10 milligram, or the patient B might drop in 20 points, actually 20 grams. So according to the measurement, mmHg. Both followed the same treatment. Both no belongs to the same category, like age group also similar, and the BP they also do have like no before the medical test they do have like a similar BP, but after the test, okay, it does has the different variations. But why is this occur? Because this is a natural variation, right? This is the random variation. These type of a variation are considered as a random variation. So that occurs due to the their bodies, okay, their bodies, their metabolism, right? So guys, do you understand? This happens because of the random variation, guys. Can you able to understand? So because the person A metabolism is different, person B metabolism is different, right? They are genetically, and no, their habits might be different, their sleeping pattern might be different, okay, due to many other factors, okay, this variation will occur in the data. So for example, another scenario, can you able to get this variation of the data that is present in your data, guys? So these type of a variation are referred as a random variation. Could you please confirm me, guys? Do you understand? So another scenario, weather prediction. Simple, guys, weather prediction. So the weather may be forecasted. So weather may be, the forecasted might tell like tomorrow is going to be like 25 degrees Celsius tomorrow. But it might ends up with like 26 degrees Celsius, 26.3 degrees Celsius, something like that. So this is not actually the prediction error. It's all because of the atmospheric systems that have the random fluctuation, which we cannot able to control it. Are you getting it? So example, the student, another scenario, if you take an example, the student test scores. Student test scores. If you have a group of students, okay, or these group of students may be following same study hours, and they might be attended the same sessions, okay, same preparation time, same class test they might carried it on, okay, but ultimately at the end of the exam, so the students might score with a different marks, right? Few may score above 80 or above 70, above 90. Definitely these variations are going to be there. So these variations are going to be depend on their mood or sleep, right? Sleep or anxiety of interpretation of the question paper due to various other factors. Interpretation of question papers due to various other factors, these variations are going to be in this data, guys. Sometimes these variation might go extreme also, but it is not an error, but you need to handle it. You need to handle these variations. You need to understand these variations and you need to handle it, guys. See, because why it means the doctors, okay, do not worry about um uh, sorry guys, excuse me. So without the statistics, without the analysis, okay, without the statistics, without the analysis, see, without the statistics in general term, okay, in general, without statistics, that these analysis might end up with that particular drug will be working, like insulin works without statistics, without analysis, without a proper technique, proper tool, right? So that drug is actually working. That is what the final result, right? It works actually. But with statistics, okay, you would be getting some no in-depth analysis of like this insulin actually reduces the sugar by or blood pressure, whatever it is, okay, or something drug. I'm just insisting the drug, okay, of insulin or for diabetes patient, for example, okay, or no some drug name, okay, it is actually reduces the sugar by this percentage on average, and but the patient actually how many patients are actually responding to this one and with how much ratio. So every detailed analysis you can able to get it, because doctor don't just work on to did it work. The doctors will never ask this question. They don't just ask did it work. They will ask how well how well did it work across the different people. Did the drug work across the different people? So you want to give some statistical information, like no, how much people are actually getting on an average, how much people are getting the result, and how much people are not getting responded with a lower value or a lower response or higher response, so that you can adjust the dose adjustment, and then alternatives for those patients can be decided by the doctors. So that is what you do require the most of the statistical aspect in order to understand this random variation. So this randomness would be present in your data. I hope you got an idea about the randomness. I just wanted to give you some general aspect of it. Then what is a noise in it? So noise is actually also the type of a randomness, guys. This is also the type of randomness, but it is an unwanted variation. So randomness is actually like a signal, okay, actually like a signal. If the data is not consistent, but it is going to be like signal, which means that you need to focus on what it matters, and you need to take some consistent action according to the result. Okay, you should handle it. You should not avoid it. You should mandatorily handle it. You should focus on it. But this noise is actually also the randomness, but it is an unwanted irrelevant variation, irrelevant variation in the data. So you need to hide or distort actually the real pattern, or see what this unwanted irrelevant variation will happen, that might hide or distort the real pattern of your data. Guys, are you getting, guys? This is an unwanted, irrelevant information. These also it's going to be like random, but undesirable. But undesirable. So if you make this unwanted, irrelevant variation in your data, then it might mask the true underlying pattern. So you need to actually remove it, or you wanted to you wanted to filter it. Either you want to remove this noise. Sorry, guys. For me it's either you wanted to remove this noise, or you want to filter this noise. Okay. So it is not happening due to the natural variation. It is actually the unwanted variation. For example, for scenario, so if an electrical interference, so a temperature sensor has to record, should record actually 25 degrees Celsius for that particular temperature. But due to some electrical interference, okay, electrical interference, this records maybe like 24 degrees Celsius to 25 degrees Celsius to or 25 degrees Celsius. So there is going to be like minor fluctuation is going to be there. So this fluctuation is going to happen in every few seconds. So every few seconds, right? So the data, whatever it is going to get absorbed, okay, observations. So these data are going to have these fluctuations. So you can able to manage this fluctuation either to identify to using the statistical technique of identifying the average of it. Either you can able to manage it. You need a statistical technique to handle it, or else if you find it that uh, that this is irrelevant, you should actually filter it. You should actually filter it for such instances in order to. It depends always on the problem statement. If you want to make some pure consistency in the record, then you need to drop it actually or remove any of the noise or any of the error that is in your data in order to maintain pure consistency in your data, right? So or else you can manage it, means you can able to manage using the statistical measures also. See, for example, yeah, in healthcare, okay, this is one scenario. Do you understand, guys? Are you getting it? Is that clear for you? So another scenario, it's a wearable device. For example, in a wearable device, I'm just showing what are the possible ways that no these errors, these randomness, these noise would be present in different types of the data. So possibly, no, it would help you to actually detect and then try to handle it in a different aspect before we enter into the statistics. So in a wearable device, if you're just going to do it, it is going to record the or patient record, whatever it is. It is a fitness watch. So it is showing now that the user has burned actually 900 calories in an hour of sleep. When the person is sleeping, actually this is recording that that the person is actually burning the 900 calories. This is actually the noise source, right? It might present in your data. So this is because the user might accidentally wore the watch too loose also. Too loose also, the user might wore the watch. So due to that also, the sensor might misread. Okay, the sensor might misread the data. Misread the data as 900 calorie. Right, so you can implement. So if such a type of a data has been recorded, okay, if you do see that no, it is an irrelevant combination, right? When a person is at sleep, actually it is recording 900 calories. So what is the activity that person is doing? The activity that the person is doing is sleeping, but the calorie it has been burning, it's 900 calories. It's completely irrelevant. Okay, so you might actually get to present this is the irrelevant combination. Then you can able to remove it using the z-score threshold or whatever outlier detection. You can able to detect that as an outlier or extreme noise, whatever it is. You can able to remove this noise or filter this noise. You can identify and then filter such noises in your data. So these are all considered as a noise, guys. For example, error. So error in a data, then what should be the error? Error is completely a miscorrect or incorrect data. Error is going to be like incorrect data, guys. It's going to be like inaccurate data, inaccurate or wrongly entered data. So it might be because of the human mistake or faulty sensors or misconfigured systems or mismatched formats during the encoding, whatever it is. But the data is actually completely incorrect, and this is a mistake. This is a mistake. You need to remove it. You need to remove this error. For example, if the age of a person is recorded as like 285 instead of 28, if they entered as 285, do you think that this is actually any randomness? No, it is not any sort of the randomness. It is completely an error. It has entered by mistake. Are you getting, guys? So you need to identify, you need to remove it, guys. You need to identify such an error data and you need to remove it. So might be the temperature might record it, okay? The even in the temperature might be recorded as like minus 99 degree, minus 99. Sometimes you do have a value like this in the temperature column. So this is also an error, right? There is no negative values in the, it is physically impossible like indoors, right? In indoors, minus 90 degrees Celsius is physically impossible. This might be like sensor glitch or disconnection. It is completely error data. You could able to get it. This is not a variation, this is an error. Can you able to identify the difference between randomness and noise and then error, what it is? Can you be very specifically, can you able to distinguish, guys? Could you please confirm in the chat window, everyone? So bias, another type is a bias. So we have already discussed about the bias. Bias, as the name suggests, it is like favoritism. It is like favoritism. So the by default, our system is actually following this favoritism in most of the areas. So if you do have like a data, for example, if you do have like a data based on the gender, for example, applicant ID based on the gender, you do have like gender, age group, and qualification, and everything is going to be like experience is also going to be like higher, and shortlisted. You do have like a shortlisted, so that your system has to actually select a people for like hiring system. It's going to be like a hiring system. It has to select based on the applicant's information. So applicant ID and male, gender is male, and then 32 and 5 years of experience, he's shortlisted. Yes. So applicant ID 2, okay, he's a male, okay, he's like 38 years old, and he might be like 3 years of experience, he might be yes. So another data might be having like another data might be having like female, like she might be like 29 years old, okay, she might be done even the PhD in the qualification, whatever it is. Her experience might be like 8 years of experience or 6 years of experience, okay, but it has been shortlisted as no. So even another female. So all the data in this female, like most probably the females will not getting shortlisted, even if they do have like more experience than male certain times, okay, and also they are not getting shortlisted. This is all biased actually. So based on the gender, the information has been recorded. So all males have been shortlisted even with a lower qualification, whatever it is, because the system learned from the past data where males were preferred, where males were preferred. That's why the system is actually trying to predict in this manner. So such data are called as a biased data. So based on due to some other it is discrimination. It is unfairly. It's going to do the discrimination in the data. This type of a data is going to be available in your raw data. Definitely, this kind of bias is going to be exist in your data. Definitely. Yes, no, guys. So like granularity is also another type of a factor that affects the data quality. Granularity. It's a level of the detail or resolution that is present in your data. So the data might be very detailed, okay, like high granularity or low granularity. So it always depend on your problem statement, like how much you do want, you can able to make your granularity level according to the requirement. Sometimes from high to low you need to convert, from sometimes you need to convert some low to high granularity. So which means what? High granularity means for detailed description, it is going to have some summarized or aggregated description about your data. So sometimes it might result in inappropriate or inaccurate granularity for like mismatch in comparisons or loss of insight. If it is too much of aggregated information, or it might hide the original trend, or it might loss of insights, detailed insights of the data. So that time you need to go for the higher granularity. Right? So the data might be recorded as per the date, for example, 2025 5/1, and the product ID and sales is 5. In this particular day, the sales is high. Similarly, 2025, okay, 02, per particular day, the sales is actually 7. So third, it actually recorded only per month. Okay, this month it shows like overall data. Okay, if this is going to be available in your data. So last row actually shows the monthly aggregate. This row it shows the monthly aggregate. This shows the daily sales. But this causes like it might cause like duplicate counting if you combine both. So you have to choose any one of the granularity level, either daily or monthly. Either in order for analysis or do model building, you want to choose the granularity level. Either you want to take up upon the daily one and then monthly one. Right? So detail if you're just giving, so that will come under high granularity. If you're just reducing the detail of it, then it will come under the low granularity according to the aspect. Just understood what is what, guys. Just understood what is what. Right? So if you want to get the customer feedback, okay, you might be having like no feedback ID, okay, feedback ID or customer ID or city, country, feedback. So these are the features might be available. So feedback is captured at the different granularities here. Okay. So you wanted to standardize. If your model needs the customer level granularity, then drop the general ones. So alternatively, you can label them differently. Right. Or else if the feedback has been collected based on the city wise, okay, you need to focus on the city and then feedback. Or if the feedback has been collected based on the country wise, okay, you need to focus on country and then feedback. So depend on your problem on the analysis, you need to focus on the granularity of the features. On what basis actually. So rather than including every detail aspect beyond the requirements. So what is the requirements, and depend on it you need to expose all the information, guys. You want to do all the information. So similarly, you do have like missing data. You are aware about the missing data, right? So there are a lot other factors are also there, guys. Lot other factors are also there. So I want you to just take a few moments to explore the factors that affects the data quality. So what are the factors we have just discussed? Right now, I want you to understand, and then understand right now, guys. And please confirm me whether you got the concept in the chat window, like bias, error, randomness. So in order to handle such a variation of these factors that present in your data makes your data is not consistent. It completely makes your data inconsistent. So that's why the statistics come into the picture. So confirm me in the chat window, guys, if you do understand clear. Type clear in the chat window if you're just getting the concept of factors that affects the data quality.
Suganya, this is Ramesh.
Yes, please.
I see. Yeah, you were telling like a lot of features and other things. Yes, while telling like yes, we are understanding, but when we go back and recollect those things we are losing out, is there any document or something like that that we can get so that we can verify or refer in future or something like that?
Yeah,
Is
I
there
do
any?
share. I do
Okay,
share
okay,
the
okay,
document. Okay.
okay. Okay, because even now, if you ask us to tell what are all the things, maybe we cannot, because yes, we are understanding at the high level, but all those things to say that it is very difficult. So if you can provide that, basically that will be good
Yeah,
for
definitely
our
I do
future.
provide. I do provide the basic aspect. So everything you would be getting from ChatGPT, right? All the informations, everything is you will be getting to understand actually if you just do explore the ChatGPT. Otherwise, I do share the resource also. I do share the resources. So I hope you got some clarity about the factors that is actually impacting the data. So whenever you're just um, if I show you some data to you, would you be able to actually identify what are the noise that present in it? Okay, let me share some data to you right now. Like few data, for example, okay, example scenario data. So I've just created 20 records. I hope you guys can able to see this data, right? It's a simple data that has been purposely, intentionally designed in order to identify these factors. So in order to maintain the data quality, you need accuracy, completeness, reliability in the data, and relevancy and timelessness. Can you please observe this data and can you please make a point out like what are the factors that you can able to catch it up? Outliers are the extreme data points. Okay, we will discuss. Okay, some of the things if you missed out, we would be actually explaining it to you. There are many other factors are also there. If you see the null values, can you able to get it? I hope you guys can able to see my screen.
Yeah.
Yes, NaN value. So these are all come under the missing values. Already you have aware of it. Right? NaN values are the missing values. And you do observe the age. Also, you do have like NaN values here. And here also you do have like none. Nothing is there. It would also represent as the NaN value only. Do you observe the age? Actually, it shows like 1 or 2. It seems like little bit higher value. It's likely like unrealistic, like customer data. Yes, if you do see the gender, the values are not standardized actually. You do have like male, female, the values are not standardized. So you can be considered these data are like inconsistent data. The data are not standardized like other, you do not know it. It is all ambiguity. You can get this under the ambiguity like other or unknown. Okay. And you can also get to present there is a redundancy of data. Redundancy means what? Repeated data or means duplicated data. You see, age 29, 101 customer ID. The age is 29. He is a male. His income is 55,000. You see, it's 29 male, but 55,000. But the date might be different. Sign up date might be different. Okay. But this data is actually occurring two times. When you want to do for the customer segmentation or some analysis, you don't require this duplicated data of the customer with the same income or same details. These are all called the redundant data. Do you observe it? And if you see the purchase data, right? Purchase data. So most of the data, it says like yes. It has been categorized as yes. Few datas like only one data actually it shows like no. Like even if any classification model, okay, if any other categories, okay, if it is going to be like most of the data are going to be fall under one category and remaining only few is going to fall under another category, then that type of data would be referred as like imbalanced or biased data. Imbalanced or biased. It is going to be like imbalanced. It has some bias. You need to focus on it. Sometimes due to the bias or sometimes due to the imbalance. For example, genuine and then fraud transaction data set. So you'd be having like 95% of data are going to be like genuine transaction in the category. Remaining 5 transaction would be like no, 5 transactional data is going to be like no fraud transaction, right? So there is going to be like imbalanced data. So this imbalance, you need to handle it. You need to, first of all, you need to detect and you need to acknowledge that the data is imbalanced. Though it might be realistic, you have to acknowledge that the data is imbalanced. Only then you will be balancing the data for model building. So all these are required. So you can able to see the income also. Income, any extreme income is available here. So this shows some extreme value, right? When compared to other income, this shows the extreme income. And also the age value is also like higher and income also seems like extremely higher. And you see the date also, it is not relevant to the current information. Can you compare the dates? It is like a past history. So everything is actually January month, like no first month data. These are all the first month data. This data is also is from the past actually. It's not relevant to this particular analysis. So you can completely get that this data might be like no error. This might get into the data due to an error. So you can analyze it. And then you can finally you can drop this data in order to maintain some consistency in the data. So likewise similarly you can make some you can handle other factors also. Do you understand, guys? Just get present. Just get present. So another scenario also let me show, and I want you to actually tell me what type of factor is that. I hope you guys can able to see my data, right? So what type of factor that is actually impacting here? So this is a city type is one data, right? City type is one data like urban, rural, and semi-urban. This is like approving. So for any loan purpose, whatever it is. Okay, this is the approval. So you see who are all actually getting approved and based on the city type, based on this particular feature. How the data has been recorded, what type of factor it is impacting. From the examples we have discussed. Can you able to make a guess?
Yes, I do have a question.
Yes, Hinsopo.
Yes, would you mind sharing the data type, like a material that will explain, like a kind of give us a reference? So then,
Definitely, because I do
yes.
have it.
Otherwise, there is
Yeah.
no way I'm gonna be, you know.
It's difficult. Is it difficult for you from the explanation, whatever I just given? Is it difficult for you to make a guess?
Well,
It's basically
it's
biased.
not.
Yeah, exactly. Very good, Mangesh. It is basically bias. You can see, na? It's biased based on the city type. See, only urban people are getting approval. So rural people and semi-urban people are not getting approval. Do you understand, Hinsopu? So you do have like only two categories of data, yes or no, okay, approval. So you do have like a type of a city, like rural and semi-urban and then urban. If you see no means they are not approved. Yes means they are approved. Like rural tells you like how many records, like how many approvals are there, how many not approvals, like 3. Which means there is no approval at all here. NaN value means there is no approval at all. LAN means not a number. For urban people, for all the people, it has been approved. Whoever urban people is there. So this type of a data is biased data. Can you able to capture the type of the factor that is actually impacting? Yes, let me share. Actually, I have just roughly prepared. Is it okay if I share you at the end of the session? Is it okay? During the end of the session?
Okay, sure.
So it will be available in the portal. Because I need to close all the documents and so if I want to share, no, I need to close all the documents and I should share. I'll be definitely sharing at the end of the session. So guys, so why do we need statistics? So that's what I just wanted to show like all the factors here in this data because these are all some of the challenges. Okay, so without statistics, we cannot able to interpret much detailedly about all these aspects, and also we cannot able to handle it efficiently. That's why we do require the statistics. So statistic, it's one of the field from mathematics. I think this is the data which I'm sharing it to you. Statistics is the field of mathematics actually in order to analyze the large amounts of data that involves in collecting, analyzing, interpreting the large amounts of data with the different tools and techniques in order to understand and to make interpretation and to give you some actionable insights about the data. So you can make some business decisions, like meaningful decisions for your relevant field, okay, based on the statistics. That's why we do require the statistics. For data science, statistics is going to be like foundation in order to understand the data. So there are two types of statistics, broadly, we can classify the statistics under two categories. One is the descriptive statistics, another one is the inferential statistics. So what is a descriptive statistics? In the descriptive statistics, guys, you can able to understand the data and to summarize the data in the descriptive statistics. Just to understand, like EDA, definitely exploratory data analysis, we would be actually using all the aspect of the descriptive statistics to understand much detailed aspect of your data. Like measures of central tendency is again the division of the descriptive statistics. To understand like higher concentration of the data, where the central distribution of your data points have been there. And measures of variability, like how much your data has been spread out in the distribution. So why do we require all these different aspects? So we will be exploring. And the graphical representation, all the visualization tools like histogram, KD, scatter plot. Okay, so even in order to build a machine learning model, you do require to visualize your data using the various visualization tool. These are all comes under the descriptive statistics, like to understand the data, underlying pattern of the data. So just to understand the data, guys. Whereas the inferential statistics gives you the insights in order to derive some meaningful action into your data. It gives you some interpretation. It gives you some deeper aspect of your data to interpret by implementing with the various hypothesis testing. By doing some various statistical testing, you would be actually deriving some inferences about the data, and you can able to make some meaningful insights from this data using the inferential statistics. Are you clear about this concept, guys? Descriptive statistics and inferential statistics. So descriptive statistics is just to understand your data or to summarize the data, right? Whereas the inferential statistics will work on with the various hypothetical testing between the population and the sample. So population tells you the entire data, okay, entire collection of the data. So you do have like real-time data is going to be like millions of data are going to be there. So you cannot able to make an inference with a millions of data. So you'll be extracting some sample of it and try to implement onto the test, even for the drug testing. Okay, even if even in the real time, uh, all the PhD scholars would be definitely implementing this inferential statistics onto their research papers in order to prove that whatever the sample of information they have been implementing that particular drug or no particular tool, okay, or particular system which has been applied onto the sample of people, and they would be doing some various inferential statistics onto it, various hypothetical testing onto it, and to prove that this particular drug is going to be like implementing the same properties for the entire population. So that can be actually you can able to statistically evidently prove based on the inferential statistics. So you can use the inferential statistics, you can draw a conclusion. Descriptive statistics is to understand in simple, guys. Inferential statistics is to draw a conclusion. So based on population and then sample. Definitely inferential statistics will work on with population and the sample. Population means whole data, right? It represents the whole data. So where you would be extracting a sample from it. Sample, you do have like different types of the sample, guys. Like stratified sampling, random sampling, okay, different types of the sampling. According to the requirement, you will use that particular technique to extract the sample from the entire group, and then you will be doing some testing onto it. Do you understand, guys?
Yes.
Yes. Okay. Shall we start with the coding? I think you just got some overall idea. What is the statistics? What are the different types of statistics are there? And why do we require the statistics? Why do we require the statistics? Because these are the several factors are going to be there in your data. You do require some proper systematic tools and techniques to deal with such a raw data, raw and noisy data. So we are using the statistics. Statistics has the different types, like two types, descriptive and then inferential. Descriptive statistics is to understand the data, whatever the tools we are just going to implement, it is just to understand the data. And inferential statistics, using it, we can derive a conclusion about it, right? By performing the various hypothetical testing with the population and the sample data, right? Sample data. So first, let us start with the descriptive statistics, guys. We'll start with the descriptive statistics. So descriptive statistics, as you said already, measures of central tendency. It is simply a mean, median, mode. So the factor, what you wanted to understand about the mean, median, mode, let us see with an example. So since I'm going to start it right now, I'm importing with NumPy as NP, because NumPy class will give you all the required information for doing a statistics. So import NumPy, sorry, pandas as PD. Not pandas is not required right now. Import matplotlib.pyplot, because we do display some visualization tool. Pyplot as PID. Okay, even if pandas, okay. Import Seaborn as SNS is also the visualization library. So it's an advanced visualization. You have to use along both the Matplotlib and Seaborn packages. These two libraries would be giving some sufficient visualization tools for you to explore. There are a lot more visualization libraries are also there apart from this Matplotlib and Seaborn. So using that also you can able to explore, guys. So from scipy.stats, it's one of the module. Scipy is one of the package. From the scipy package, you do require the stats module to import mode. So if you want to implement the mode, then we do require this stats module to import. So I'm just going to create with, let us start with some simple data in order to understand. I think we have just started with the last session also, it seems. I just wanted to use the same data for you. I don't know. We have seen this example, right? No, guys. So mean is equal to NP dot median equal to NP dot median of data. So if you want to understand mean, what is a mean? It is just an average. Mean can be identified by calculating the total of it divided by total number of values. So that is going to give you the general average of your data. So according to this data, what is the mean? Median tells you the 50 percentile of your data, which means what? half of the data, it is also going to give you the representation of the average, but it gives you the 50th percentile of your data. So how to identify the median? Actually, you do have like, no, if it is going to be like odd number, the total number of values are going to be like odd number, you can choose the middle value of it. If the total number of values are going to be like even number, then for median, you need to choose the average of the middle two numbers. So this is for median. Right? So if the number of values are going to be like odd, like 1, 2, 3, 4, 5, 6, 7, okay, it's odd number means you have to sort out in ascending order. First of all, sorting out as ascending order it's a mandatory thing when you're just trying to calculate the median, and try to choose the middle value for it. The first step is sorting out in an ascending order. Second step is to choosing the middle number if the n value is going to be like odd number. Right? If the n value is going to be like even number, if you just count on it like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so total number of values are going to be like 8, which means n value is going to be like 8. This means it is an even number. So you want to identify the average of the middle two numbers. If you try to average of the middle two number, that is going to give you the mean of it, median of it. Right? So in the similar manner, we do get the mean and median are going to be same number when in case of the normally distributed data. So data will follow the normal distribution where mean and median will remain in the same position. It represents a symmetric distribution. Right? So because all the data are going to be like consistent, normally distributed data represents like all the data is going to be like consistent, which means you can rely on to this data for analysis. There is no any ambiguity, anything, so you can rely on this information. It shows like consistent data. If normally distributed data is going to be like consistent data, other than we just dig and deeper and then analyze much deeper aspect according to the domain information, like semantic understanding of the data. If so still it is there, okay, according to the domain knowledge, still we want to go and explore the data whether any relevant or not. So that is an advanced level. So next I'm just going to create a data with outlier. I think we have discussed this step in the earlier class, right? So data with an outlier means actually we are just going to choose the same data in order to show you the difference, okay? Only one data is actually I'm just inserting as an extreme value. That is an outlier. So you can enter mean with outlier mean. Okay, outlier mean. Mean equal to NP dot mean of data with outlier. Right? Outlier median. Data with outlier, print median. I hope you can able to identify the deviation, guys. Right? So mean in the normal range, mean and median are going to be like same. Whereas here, the mean actually gets deviated towards the extreme value, because the extreme data is here, it is a 61. Only one data we do have like no extreme data. I'm just showing this for an example. whereas the median is not actually getting dragged by the outlier. So median is consistent actually. So median, we can represent it is a robust to outliers. So whenever you do have like a data with an extreme outliers or the outlier data, it is always to use the average value as the median data than the mean. So mean is not going to be like reliable. So only median is going to be reliable for the outlier data. Right? So we have also displayed a distribution of it. So KDE distribution, we just displayed it. Guys, I've just copied and pasted in order to avoid timing. Okay, let me type outlier data here. In order to save the time, because we do have like a lot more to discuss. Outlier median. I'm going to create a subplots, guys. Subplots means what? More than one plot I can able to display in a single figure. So where I'm just setting up the figure size. So not single figure, okay, single space, okay. So where each figure actually consists of the figure size is like 10 comma 2, 10 comma 5, okay, height and width of the figure size. Each figure consists of this figure size. And I'm going to have a subplot, which means one row where this subplot is going to consist of 2 columns. One record, which means 2 columns. So this plot, it's going to be like no first plot. 2 columns we have said, right? Right, one row. Sorry, why it is. I'll try to improve my handwriting, guys, but okay. So one row, 2 columns. So first plot, this is going to be like first plot. That's why it shows like this. So only one record is there, but 2 columns, right? But this is going to be like first plot, whatever we are just going to enter here. Do you understand, guys? So this KDE plot is nothing but kernel density plot, guys. This is especially is for to check out the distribution of your data. So where the distribution, whether it is a normal distribution or skewed distribution, especially you're going to have these range of data or bimodal distribution. If you do have like no bimodal distribution, whatever it is. Okay. So, but normally distributed, it's going to be like no consistent data. This data is going to be referred as a consistent data. Or it can show the data skewness. If there is a large variability is there, the distribution is going to be like this, if there is a large variation. So over the time, you will get to understand what is the type of distribution you will get to interpret with all the type of interpretation. So KDE plot, it will show the distribution of your data. So next in this plot, in this distribution plot, fill is equal to true means, so we can able to fill the color under the area, right, of the distribution. It's a simple line plot. that shows the maximum concentration of the data points, density of the data points. See, axis vertical line. I'm going to plot a vertical line that is going to represent the mean in red color. I'm just defining the red line style as the double dots. Okay. I'm going to define a label as mean that should consist of the mean value with the two floating point representation. Can you able to understand this one? Clear? Can you able to follow me, guys?
Yes.
Could you confirm me, everyone? I hope everyone is following.
Yes.
So
Yes.
similar way, I'm also displaying another vertical line, okay, to represent the median in that particular distribution. That is actually, I'm just showing in the green color. The line style is dashed is the line style, and I'm just displaying the label as a median. I'm just giving the median value. This is the variable name. Okay, it has the value in it, right, with the two floating point representation. And I'm just displaying the original data. So first plot is going to be like original data, and the X label is going to be value, and Y label is going to be density. I'm just going to plot the legend in my plot. So all these one I have to define using the matplotlib, like PLT and then SNS. So these are all the PLT objects, right? Which means what? Matplotlib object. This is the Seaborn object. Right? And in the same subplot, okay, with one row and then two columns. So this is going to be fall under the second plot. So the second represents the second plot. So similarly, one row and then two columns. So what is the data I'm just going to display? I'm just going to data with an outlier. That for that data, I'm just going to display the KDE plot. So again, I'm just plotting the two vertical lines, the mean of this particular outlier mean and then particular outlier median data. I'm representing the same information here. So finally, you want to give the statement plt.show, guys. It is so mandatory. Otherwise, your graph will not be visible in your output window. Your coding will be successfully executed, but you cannot able to see your graph because of the this information. So you need to give this plt.show mandatorily in order to see the output in your output screen. So as I said already, the original data is going to consist of the similar range of the data. That's why it shows like both the points have fallen here. So since green color is actually dominating the red, that's why we cannot able to see the red color. Red color is also present in the same line. Okay, so median, mean and median falls in the same line. So this type of a distribution is called normal distribution. Where the symmetrical distribution. This type of distribution is called the skew distribution. Where the data here, the red color mean line is actually skewed, deviated towards the outlier. The outlier present here, right? Like 61 is going to be an outlier. So this we will actually have the deviation towards the outlier, whereas the median will not get impacted. So where the median tells you the original density of your data point, right? So where the original density of the data point lies in this distribution only. So the median gives you the exact information, but mean is actually deviating. It is not showing up the original distribution C. It is actually deviating towards it, where the most concentrated data points are going to be here only. Right? So in this value would be considerable value for in order to understand this particular deviation. So this is called right skewed, guys. So this sort of skewness is called right skewed, or also called as the positive skewness. If the skewness is this side, it is going to called as the negative skewness. Or left skew. So where this represents the mean, right? And this represents the median. So where mean is greater than median here. When mean is greater than median, actually you do have like no right skewness. Here, when median is greater than mean, which means what? Mean is lesser than. Mean is lesser than median. Which means what? Negative skewness. Your mean value would be lesser than the median value. If in case of the negative skewness. Where here, in this space, mean equal to median. In fact, mean, median, mode, if there is a mode value is also there in your data. Right now, this data may not have a mode. So in fact, mode value is also there. Mean, median, mode. If both the data are going to be like fall in the same region, only then that is a perfect symmetrical data, in fact. So all three will fall in the same place. Here, mean is greater than median and greater than mode. Here is mean is lesser than median and lesser than mode in case of the negative skewness.
I do have a question.
Yes, please.
Yeah, so can we say, is it the same thing if I say since mean equal to median is a normal distribution?
Exactly.
Okay.
If mean equal to median equal to mode is a normal distribution. It's a normal distribution. It is also called as a Gaussian distribution. Normal distribution is also called as a Gaussian distribution in statistics. Where here, simple guys, here the data is consistent. Here the data is having some outlier, some skew data. You need to focus on actually what is the value actually it is dragging out. It is a signal to actually check out whether that is actually because of due to the randomness or due to the noise or due to the error or what it is, you wanted to check it out. So depend on the type of a data, value of the data, you need to handle it. If it is going to be like due to the randomness, okay, due to the signal, okay, you need to handle it, not remove it. But if that value is going to be like error value, if it is irrelevant to your data, you need to remove it. If it is a noise also, you either you can impute it or you can remove it, whatever it is. So there are a lot of ways to detect that noise also in your data. Do you understand up to this, guys? So mode, if you just wanted to calculate the mode, okay, I do have like no, I've just started to explain more. So if you do have like a data equal to np dot, okay, is it okay if I just do copy paste? Is it okay, guys? You guys can able to follow me, right? So understanding the type of a skewness. Okay, where mean, median, mode is going to be like in a single strand where it is considered as a normal distribution. It is going to be considered as a negative skewness, and this sort of skewness is going to be considered as a positive skewness when your distribution is following this aspect. So I'm just creating one data where it is going to consist of the frequency of the data, like 2, 2, okay, 3, 3, 3, where more number of occurrences. Especially the mode value would be best suitable for the categorical type of values, like yes or no, okay, male or female, okay, that like this type of a value, you can able to get the central distribution of the data. So here also it is an finite number of categorical value, but numerical categorical values, discrete values. It would be like best suitable for the discrete type of values to identify the mode of it. Okay, which means that frequency. Like mode is what is the mode? Like highest mode is actually 3. Like highest occurrence, like frequent occurrence in this particular data is 3. That's why it has been given as a 3. If you want to see the count of it, then I can use this option also, use this attribute also to check the count of the occurrences. So this 3 occurs for the 4 times. Even if I give like one more time, it would be displaying as a 5. So 3 occurs for the 5 times. So this is to see like a single mode value. But if you want to see a multimodal value, sometimes your data might be consist of categorical data, might be consist of the 2 or more data also. 2 or more data also with a similar frequency. So if you wanted to get a multimodal data, okay, for this we can define using the statistics, okay? Because the multimode is a built-in function that comes from the statistics. Statistics is another library, another package that you can able to implement in order to access this multimode built-in function that gives you if there are 2 or more numbers, more categories that occurs in the same frequency, it is called as multimodal. It is right now it is a bimodal, right? Only 2 features, 2 datas are there, 2 categories are there. So it can call it as a bimodal. If there is more than 2 categories that occurs with the same occurrences, then it will be referred as a multimodal. So if you want to see more than one mode frequency, you can make use of the multimode built-in functions. Okay, guys. So let us create some meaningful insights from the data. This is also another simple data, because why are we actually working on the simple data? In order to understand, first of all, in the beginning aspect, right? What it is actually. We will try to extract. Consider this data just only 10 data. Okay, consider this data. I want you to identify the mean of the delivery time. Mean of the delivery time. What is the mean of the delivery time in this data? I think you do guys get my file. You do get the data. Whatever I'm just showing it in your screen at your end. I want you to find the mean, median, and then mode of the delivery data.
Where did you share the file? I didn't receive the file in the chat.
I have shared in the beginning itself. Okay, let me share one more time. I didn't share. I have shared already. Wait.
Sorry, I joined late. Like.
Okay, fine. That's okay. So consider this is a food delivery data. Okay, delivery in minutes. Okay, delivery time in terms of minutes. Like these are all the minutes of time. Like 25 minutes, 22 minutes, 20 minutes, 21 minutes, 19 minutes. Okay, 21 minutes, 23 minutes, 22 minutes. So what is the mean of it? So DF of delivery time, okay, it is going to give you the mean.
Yes.
And DF of, yeah.
Oh, sorry. The mean is 23.8.
Okay, exactly. So mean is 23.8. Right? Median is actually 21.8. Here, the mean and median is not same. Right? Here in this data, if you identify the mean and median, it is not same. It is not equal, which means you can get that the data is skewed. And also the mode value, it ranges from like 21, 22, 23. These are the frequent delivery minutes that actually happening in this particular data. So mean is slightly deviated towards the which means the mean value is greater, right? Mean value is greater than median. You can get that this is a positive skewness, which means the right skewed. The data is actually right skewed, which means that higher value, you do have like no extreme value, little bit of extreme value. That's why it's skewed towards the right hand because it is greater than median. Can you able to get this one? So what is the data which has been skewing? So all of the remaining data are in the similar ranges. Only the 45, it's going to be like slightly, it's going to get skewed. 45 is going to be like no data which has some deviation. Can you able to understand? So median tells you, see, mean tells you, okay, on an average. But this average is actually deviated. But median gives you the average where the half of, always the median will tell you the 50th percentile of your data, which represents always the half of the data have been falling, which means what, half of the customers are receiving their delivery in less than 21.5 minutes. This is what the interpretation you want to get it. Median always tells you the half the data set. So if the data set is going to divide into two halves, okay, so the first half is actually following the median. So all the data which actually falls within the less than or equal to median. It typically represents that half of the customers receiving their delivery in less than or equal to 21.5 minutes. This value, it's not going to get distracted due to an outlier. So it is a strong measure. It is a strong typical measure according to this data. So among these delivery times, okay, what are the most frequent delivery times are going to be like 20 minutes, 21 minutes, or 22 minutes. So the majority of the delivery minutes are going to be like, no, the most customer, which means what? Most customer get their orders between like 20 to 22 minutes. So this is going to be like common time slots. Right? Can you get the interpretation, guys? So you want to investigate what makes this deviation. So when mean is greater than median, it tells that the data is actually deviated. Okay, which means what is the average delivery time? It is sensitive to delays. You wanted to investigate what is the delay, why it is actually deviated towards this skewness. So without statistics, you may assume that average delivery is like 24 minutes without statistics, which actually masks the issue, which will hide the issue actually, underlying issue. So on an average, if you find out the average, okay, on an average, you can say that 24 minutes of delivery is happening according to this data on an average. But with a real exploration, you can get that only on an average, most of the customers have been receiving their deliveries only 21.5 minutes. Yes, no, guys. So you need to investigate and you need to create some you need to improve the business actually in which actually specifically either the driver or the route is making a delay or whatever it is, you need to still investigate according to the business time insight. So still more, if you are exploring, you need to identify the range of it. So what is the range? Range gives you maximum value minus minimum value. So max of data minus min of data. DFR, I'm sorry. Okay, I should give only the delivery time. So it tells you that 26 minutes. The range of this particular data gives you 25 minutes. This tells by range, minimum value minus maximum value minus minimum value. So it is a spread in delivery performance. It shows like no inconsistencies. Like how to detect it, there is a thumb rule. If the range value is a 2 times of IQR. Okay, let me introduce the IQR also. So always you can compare the range with the interquartile range, guys. Interquartile range. So range is actually the general range between the maximum value and the minimum value, right? Which is the maximum value and the minimum value. So IQR is also another analysis, guys. IQR. It is representation of interquartile range. It is so important, guys. These are all important aspect. Where actually it gives the interpretation of Q3 minus Q1. Guys, first let me explain with an example. Okay, then I will show you what no what is this no with a box plot. Okay, especially box plot you can able to represent using the 5-number summary. So let me explain it, then you will get to understand. I hope you are all with me, guys. Can you able to understand, guys, what I'm just communicating to you? Can you able to understand?
I have a question.
Yes, please.
Could you please scroll a little up and yeah, here. See, with this descriptive statistics, the mean, median, and mode, we got these things, right?
Yes.
So can we interpret or something like that with this data? Is it a normal distribution or left skewed or right skewed? Or is it too early to do that?
Yeah, we can do it. No, it's not
Because
early. It's not. It is all depend on the requirement. You can here itself you can able to do it. So here with this data itself you can able to generate. Okay, to see whether it is this thing generate a distribution.
why I'm asking is almost 3 of them are falling within a 1 point range, right? So yeah.
Can you able to see the skewness? So
Yeah.
the 45 point is here and the other range of values are here. So most of the concentrated data points have been lying here. So when you want to take any business insights, any business action relevant to your improvement, improve your business, okay, you need to focus on most of the concentrated data points. Like no giving some offer, whatever it is in this particular average group of people you want to give in order to improve. And if you want to address any issue relevant to the business side, okay, you need to focus on this actually deviation. What is an issue? You need to rectify this issue. Either it is occurring by chance or by an error, or the data has been entered by an error or mistake of a human mistake. So all these aspects only we have already discussed. So you need to explore.
Okay.
So the moment you just load the data, even with the noise also, you can able to explore the distribution, graphical aspect. And if you want to see much in a quantitative measure, what is it? The mean, what is the mean? What is the exact mean, median? Then you can make use of this representation. In fact, you don't require to give independently. You do have like no function called describe. That's what I'm just going to give you. You do have like no specialized tool called describe function in pandas that gives you the descriptive statistics of your data, entire descriptive statistics of your data, whatever the matters. Right? It is going to give you the total number of records, the count, the number of information, what is the mean, okay, average mean of it, of the delivery time. So customer ID, we don't require the such analysis, okay? You see the delivery time, what is the standard deviation? We are just going to explore what is the standard deviation. So minimum value. So minimum value of this data starts from 19, right? So maximum value it's going to be like 45. 45 is going to be like max. So now we are just going to explore what is the quartiles. Right? So Q3, Q1, I have been started to explain. No, I'm just going to explain this factor only. So this is the median. So mean is this one and median is the 50th percentile of your data. This gives you the half of the data have been following the median. So remaining, let me explain you with the representation.
Okay, thank you.
Thank you. See, for example, we will take another example. So first of all, for any data, if you want to display, if you want to identify these quartiles and then you want to, these are the quartiles like Q1, Q2, or again, you're going to find out the median only. Median of the first quarter, median of the second quarter. Okay. So it means that you're just going to divide your data. It means that you're just going to divide into data into 4 parts, 4 equal parts. Okay. So middle equal parts is going to be like 50 percentile. And then here it is going to be like Q3, which means 75 percentile, right? Here you can determine as the, here it is Q2, okay? 75 percentile, here it is Q3. Q1, it's going to be like 25 percentile. So 25 percentile, 50 percentile, 75 percentile of your data. So entire data, you're just going to divide. So this is the minimum and this is the maximum. So your minimum data from the minimum value till the maximum value, you're just going to divide your data into 3 quartiles. So for example, if we take the data for representation, like 12, 14, 15, 17, 19, 22, 24, 37, right? So how many number of values? N value is going to be like what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So N value is equal to 9, which means the odd number. Odd number means you can choose the middle value. So what is the middle value? So middle value is going to be like 19. Am I right? Middle value is going to be like 19. So your Q2, this represents your Q2. So Q2 value is going to be like 19. Which means what? Median value. It represents the 50 percentile of your data. Right? Q2. Q2 is 50 percentile of your data. Again here, this is the first half. This is the second half. Right? So in the first half, you wanted to identify the median. So what is the median? This is the even number. So you want to add these two values divided by the 2. So what is the answer for it? 14 plus 15 divided by 2. Tell me guys, 14 plus 15 divided by 2, what is the answer?
14.5.
14.5?
Yes.
Exactly, 14.5. So this 14.5 is going to be like Q1 value. Q1 value is going to be like 14.5. Right? Which means what? Q1 value represents 25 percentile of your data. Again, what is the 22 plus 2 divided by 2? Because again, the median you need to calculate, right? So this is going to represent of Q3. Yes, guys, what is the answer for this one?
And 3.
23?
Yeah.
Okay, fine. Thank you. So 23. So Q3 is going to be like, no, 23, which means 75 percentile of your data. So 50 percentile, 25 percentile, and 70 percentile of your data. Right? So this tells you minimum value, and this gives you maximum value. Right? So minimum, maximum, Q1, Q2, Q3. So it is a 5-number summary. Can you get the 5 numbers here? So first number, second number, third number, fourth number, fifth number. So your box plot is one of the important representation, guys, visualization format in order to identify the outlier. Okay. Box plot, it's going to be like, no, 5-number summary. So this all 3 representation are going to be available in your actually in your descriptive statistics. What is a 25 percentile of information, which means what? The data which is going to fall, the first 25 percentage, first quarter is going to fall within less than the 14.5 percentile of your data. It is going to consist of this value. So similarly for the 50 percentage, like half of the population or half of the group of the data, it's going to fall less than or equal to this value. And 75 percentile of your data, okay, are going to fall less than or equal to this value. So this you can able to represent using the box plot. Box plot going to consist of the 5-number summary. So in order to represent the box plot, you need to identify the IQR value. So IQR, it's nothing but the interquartile range, where the maximum middle 50 percentile of your data is going to fall in this region, which means Q3 minus Q1. So the range is going to consist of all the deviated value. Okay, it is more sensitive to outliers, the range value. So this gives you the range value. Okay, the difference between the maximum and the minimum gives you the range. Okay, between like Q2 and Q3, it's going to give you the like IQR value, IQR range value. So what is the Q3 here? Q3 is actually 23, right? Q3 is 23 minus Q1 is actually 14.5. So 23 minus 14.5, it's approximately like 8.5. So your IQR value is what? Your IQR value is 8.5. So this is the interquartile range, which means the middle distribution. I'll share you the notes, guys. All the notes I'll share you. But can you able to follow up? Do you understand up to this calculation, everyone? Do you have any doubts, any clarification up to this calculations? Guys, you are not
Yeah.
going to do.
I understood IQR, which is 8.5, but where this will be used? So are we going to say, see, the time is basically between 14.5 to Q1 and Q3. That's what you said, right? 14.5 to 23. So, but this IQR, where this will be used?
Yeah, let me show you. Okay, for example, if you do have like data, like I'm just going to create only the similar ranges, okay, because we don't have like no. So I'm just going to create some similar range of values like 12, 15 or 18, okay, in order to get that one, or 21, 19, 18, 19, just roughly I'm just creating, guys. Roughly I'm just creating 21, 23 or 22, 20, 23, for example. And so 25, I'm just creating roughly, okay, I'm just telling, okay, 25, 27 or 30, okay, 33, 35 or 37, whatever it is. Okay, so when you want to plot a box plot, okay, you need to find the upper bound and lower bound, guys. With this IQR, actually you wanted to determine the upper bound and lower bound. Okay, upper bound and lower bound. What is the formula for upper bound is to determine, sorry, lower bound and upper bound. Okay, upper bound like Q3 plus 1.5 into IQR. So Q3 is the quantile 3, right? This is the value Q3, 23 plus 1.5 is the default threshold value, guys. 1.5 is the default threshold value. Okay, 1.5 times from the IQR is going to determine as the accepted range of value. So what is the value range? It is coming up here for you. The variation, the deviation are going to be like no accepted range. So Q3 means what? It is a 23 plus 1.5 into 8.5. What is the answer you're getting?
$33.
33. Did you count it properly actually? Did you calculate it properly actually? 33, yeah? In Sokpo? So Q3 is actually 23, right? So
Yes.
23, 1.5 into, what is IQR value?
35.75. 35.75 it looks like.
Oh, it's a multiply. Okay.
8.5. Okay. You need to multiply and you want to add it. So what is the value? 30?
35.75.
Exactly, 35.75. So where is this lower bound? Q1 minus 1.5 into IQR in order to identify the lower bound. In order to identify the lower bound, you want to identify like Q1 minus 1.5 into IQR. Like 1.75, right?
Yes.
Yes. So though this is the range of value, okay, this is, I'm going to plot a box plot, okay. So it is going to start from the lower bound. So what is the lower bound actually? So sorry. What is the minimum value? Okay, minimum value is actually start from 12. I'm sorry. Minimum value, it's going to start from 12. Right? What is the maximum value here?
$37.
1 minute, guys. $37. Okay. So let me plot like 19. Okay, fine. So 19, wait a minute. Q2, Q1 is 14.5, right? 14.5, 13. Okay, 14.5 would be coming here. Okay. And Q3 is actually 23, right? 23. So this represents Q3, Q2, actually Q1, quartile 1. So quartile 1, quartile 2, and quartile 3. And this whiskers will go up to 35.75. 35.75. Okay, up to this it will go. So those values which is actually beyond this whiskers. So this whiskers is going to represent the range of values. Only 1.5 times into IQR it can display. So but here we do have like a value of up to 12. Am I right? So but here it is acceptable to go the range up to like 1.75. Even in the lesser value, the lower bound it is up to 1.75. The whisker can grow. But here the whisker cannot grow beyond this 35, because this is what the upper bound you just set. It is a new limit. It is what the lower bound you have set. But your starting value is like 12, right? But those values, we do have like maximum value of 37 here. But here the 37 will occur like an outlier, a small circle. So this is the representation of the box plot, guys. This is the representation of the box plot. How the data has been represented. Do you understand, guys? Are you getting the concept? So this Q1 represents the 25 percentile of the data. You see the skewness. The skewness is towards this end actually, even because the range of value is actually larger, but still the outlier is present. Outlier is going to be like extreme data point, which does not fall in this particular range of value. It always tells the larger deviation. Always you needed to focus on it. So in most of the analysis, like regression analysis, whatever it is, you will try to remove these outliers, not completely, but you will try to reduce the outliers. Outliers cannot be removed completely. It can be reduced using the, again, the IQR analysis. Once again, you will be plotting out with the upper bound and lower bound. When you are trying to find out the new upper bound and new lower bound, you can able to reduce the outlier factor. Right, for this data. So in this way, you can able to identify the presence of the extreme value or the noise in your data. This circle, which beyond the whiskers represents the outlier. So because how to detect an outlier or extreme range of value from your data, because you do have like no millions of data, crores of data, right? Or lakhs of data. There is a large amounts of data are going to be there. You cannot go and explore each and every data to identify which actually data are going to be like deviations. So this statistical information, okay, this analysis gives you like which data is actually falls with the extreme range of values. Automatically detects. The box plot is one of the best plot to detect the outliers like extreme value from your analysis. And this IQR range, it's going to be like most of the data points like central location, like central tendencies of your data is going to fall in this IQR data. If the data is so smaller, if this IQR, sometimes your box plot might look like this. Your plot might look like this, okay? Very, very smaller, because the data is not consistent. You do not have a consistent data here. You need to focus on the data actually, the distribution of the data here. The distribution may not be actually consistent. Sometimes the deviation might be here itself. Here itself, the Q1, Q3, sometimes deviations would be here also. So you need to focus on it. So the deviations are there in the larger the variation, it gives you the spread of the data from the mean, okay, from the average, how much the data is being spread out. You can able to detect it. How much the larger the variations of the data are there. Do you understand, guys? So if the long IQR, it represents the high data variability. If very short IQR, it represents a low variability. Low variability means what? It might be like constant feature. Like high variability, you may need binning or any other no data transformation need to be done. It depends on the distribution of the data. If multiple outliers, it's not only one circle data. So one circle represents one data point, extreme data point. So in the real-time data, you would be having like no more number of circles. So you can able to detect and then identify using the IQR as well as the Z-score, okay, various aspect to identify this deviation. Do you understand this aspect, guys? Could you please confirm me? Do you understand this math? See, guys, you do not want to do all this math, guys. It is not required. You do not want to do all this math. Okay, it is not required. But what is behind it, you want to understand, because simply know how this actually occurs in your data, you might not get to understand. That's why I'm just showing. These are all the math it is happening behind it to display this particular distribution of plot. Clear, Ramesh? Are you clear, Ramesh?
Yeah.
Okay, it's already 8. I just wanted to show up. 9. I'm sorry, it's 9. It's time up. We haven't given a break. I'm so sorry for that. Okay, guys, it's time to share the resource actually. Okay, if possible, I will share it in the chat window right now. Also, you can find all the resources in the today, whatever the concept we have discussed, you can refer the resources. I just want you to focus on, you can still explore the more factors also, like what is the difference with the more factors, you can still explore and try to understand. Because when you're trying to work onto the data, you might be experiencing with the all the type of the noise. So give me a few seconds, I will try to upload the resources for you. We will interpret with a more information, guys, tomorrow. We'll try to understand with the more business insights. Guys, I have roughly made this presentation. Okay, there is no formal notes, nothing. I've recently, because for every batch, no, we used to get like updated information, like whatever it's been updated for the current trend and current examples, we used to get it. So it's been made with the current information that too, it's been roughly made. So it's not like formal. Okay, I just wanted to insist. I just quickly made out of it. Guys, I'm sharing it in the chat window. Okay, please do find box plot. The same example I have given, the box plot. We can still explore with the more scenarios, more example to understand, guys. I've given only 2 instances. So guys, I hope I have shared all the resources to you so far, whatever I have been discussing during the session. I also do share the resource of statistics. For 1 minute, guys. Let me complete this one. So I'm just intended to complete this particular topic today. Mm. Why it is facing an error? I'm just surprised. Okay, let me remove this column as of now. Let me remove that column. Customer ID column not required for our analysis. Our main focus is to delivery time. I hope you guys can able to see my screen. So guys, I just want you to explore. Let me quickly explain. Actually, I have just taken another 10 minutes of time. Okay, fine. So this is the data. We know it. And we have already identified mean, median, mode. And Q1, in order to identify the Q1, we do have like a function, built-in function of quantile. So quantile of 0.25, which represents the 25th percentile of your data, right? So Q3 represents quantile of 0.75, which means what 75 percentile of your data can be represented using the quantiles, right? IQR is nothing but Q3 minus Q1. So you're just finding out the upper bound and lower bound. You're trying to extract the data like which is lesser than the lower bound, which is the greater than the upper bound, or going to consider as the outliers. I'm sorry, guys. Outliers are the data points that is actually lesser than the lower bound, which means 1.75. That above example we have discussed, right? So though if any value that exists beyond 1.75, like lesser than that, like 1 or 1.7, whatever it is, 1.06, then those would be considered as an outlier. And those values which is above the upper bound would be considered as an outlier. So those and can be recorded as an outlier. So that is what we are just seeing in a visualized format. So I'm just displaying only the box plot as well as the histogram plot with the distribution along with the mean, median, mode. The box plot you can able to see the outlier data according to this particular data, right? I've displayed like mean, median, mode of it. And what is the delivery time? Which one is actually the outlier data? I've just displayed it. Along with the index position, like 9th index, the 45th data. So don't confuse with this, guys. This is not a value. This is the index value. Only this is the value. Which one is outlier according to this data? It shows like 45 is the extreme data point that actually shows the deviation, right? So what is IQR? IQR, it shows like 2.5. So IQR is going to be like interquartile range. So this range actually it shows like 2.5, the range of value. Guys, could you please confirm me final, guys? Do you understand? Whatever the concepts we have discussed today. Ramesh, Michael, Ajay, Hinsokpu, Eram, Darfur. I don't know, one have been left the session. So before winding up the session, can you please update with a clear in the chat window? Yes. Just go through this file. Go through this file and go through the concepts which we have discussed today and go beyond the box. Okay, out of box. Go and explore more. So we will discuss in the tomorrow, guys. We will continue to discuss in the tomorrow.
It's showing an error at the end.
Where?
Uh,
So this data actually it is showing an error. Customer ID. Please put it in the comment line.
okay.
No, it is not showing any error. Yeah, this data. Okay, fine. I have just repeated. Right. Thank you so much, guys. Thank you all. Yes, guys. Have you left actually? Okay, fine. Hold on a moment. Let me share one
Mhm.
references also. Sorry, I just forgot to share the reference. Okay, I missed the references. Huh? Okay, wait a minute, guys. Okay, let me share it tomorrow. I have to find it out. Okay, I'm trying to get the references. Okay, I got it. Okay, guys, I've just pasted some reference. You can just refer. Okay, guys, thank you so much. Thank you all. We will continue the tomorrow.
Did you save the file?
Yeah, I shared the file in the chat window. You didn't get it
No,
actually?
save, not save, because
Yeah,
I'm not
it's
getting the updated one.
Yeah, I'm also not getting the updated with the references.
seriously. Okay, I'm just saving it.
Yeah, got it. Thank you.
Got it? Thank you. Thank you, guys. Thank you all. Bye.
Thank you.
Ramesh, do you have any clarification? Any doubts?
No, nothing at present.
Okay, fine. Shall I stop the screen? Shall I end up the?
Yeah. You can stop the recording. You can do that.
Thank
Go
you. Thank you so much. Bye.